Good morning, student. Today we will start our chapter Atomic Structure Part 4. So in our last class, we discussed about dual behavior of matter, that matter has a both particle as well as wave nature. Today we talk about the special topic, that is Heisenberg uncertainty principle. According to this principle, there is always an uncertainty regarding position and momentum of a microscopic particle such as electron that can explain mathematically by following equations. If you read the statement, then it states that it is impossible to determine simultaneously the exact position and exact momentum of an electron. There is always uncertainties in between both of them. So what does the mean of this statement? First of all, this Heisenberg uncertainty principle is valid only for microscopic domains या microscopic particles, not on a object like Earth. So first of all, it only valid for a small microscopic particles such as electron. And second point is to note here is that it is impossible to calculate simultaneously the position and momentum, because if we consider that electron is in rest, then we find the position exactly, but its momentum become zero. While if we consider that electron is in motion, then we find its momentum exactly, because momentum is the product of mass and velocity, but we are unable to find position of electron. That means both the units, that means both the quantities like momentum and positions are not measured at is on determined simultaneously. That's why it's called uncertainty, Heisenberg uncertainty principle. That principle was given by Heisenberg, that's why it's called Heisenberg uncertainty principle. So mathematically we will we was go for the conclusion. What is the conclusion? That the uncertainty in position, the product of uncertainty in position and momentum is greater than or equal to h upon 4. As you know that momentum is equal to mass and velocity, that means product of mass and velocity. So we can write product of uncertainty in position and uncertainty in velocity is greater than or equal to h upon 4 pi m. Okay, so if we have in our examination that uncertainty in position is given, then you can easily calculate uncertainty in velocity. Okay, suppose uncertainty in velocity is given and you have to find uncertainty in position, and this is all are about the electron, then you have to put a mass of electron here. That's why m is a mass of an object. If it is an electron, then you have to put its mass, that is 9.1 into 10 raised to the power minus 31 kg. Okay, so this is all are about Heisenberg uncertainty principle, and this principle is only valid for microscopic type of systems. Come to the next, our final and advanced model, that is quantum model. Complete quantum model is based on an equation that is called Schrodinger wave equation. The in brief, this Schrodinger wave equation can represent as H sign is equal to E sign. Here H is a Hamiltonian operator. Okay, S similar like division operator, like multiplication operator. It is a Hamiltonian operator which we use in our higher classes in BSc syllabus. So H psi is equal to, the symbol is called psi, PSI. P is silent here. P is silent here. So H psi is equal to E psi is a short form of a Schrodinger wave equation. So quantum mechanics is basically deals with the study of motion of microscopic objects that have both kind of nature, that is dual nature. They may behave as a wave and they may behave as a particle. The study of such particles is called quantum mechanics. Basically, quantum mechanics is based on Schrodinger equation. Okay, so this is all about the psi and psi square. So by solving this Schrodinger equation, we got psi and psi square. So what is the physical significance of psi and psi square? There is another NCRT question that asks many times in your examination. Psi represent the amplitude of the waves. Psi represent the amplitude of the wave, while psi square represent the probability of finding electrons. Okay, psi represent the amplitude of the wave, while psi square represent the probability of finding electrons. That means dictate the area or volume where probability of finding electron around nucleus is maximum. That is called psi square. Come to the next. There is a term orbital that we already heard. What is orbital according to quantum mechanism? The region of space around the nucleus where the probability of finding electrons is maximum. According to quantum mechanics, orbitals, orbits, that means shell, subshells, orbitals, all are all are the all are showing the path or trajectory, which are the mathematical solutions of Schrodinger wave equation. So basically, this quantum model is completely have mathematical proof. Okay, so quantum model is, that's why is advanced and well applicable, most applicable. Okay, quantum model is based on another pillar, that is quantum numbers. The first pillar is Schrodinger wave equation, and second one is quantum numbers. Basically, there are four type of quantum numbers which explain the different parts of an atom. For example, principal quantum number, which explain which is generally discovered by, which given by the Niels Bohr in a Bohr model that comes from there. So principal quantum number explain or give the information about shell, nomenclature of shell, size of the shell, velocity of electron in a shell, and energy of a shell. So all are about the shell. All information about the shell is given by n. That is your principal quantum. Another quantum number in a series is azimuthal quantum number, that is represented by small l, giving all information about subshells. A similar third quantum number is the magnetic quantum number, will give all information regarding orientation of orbitals and orbitals also. That means it will give the shape of different orbitals. Come to the next, spin quantum number, that will give information about the spin of electron in its trajectory path. So this is all are about the four quantum numbers. So basically we have quantum model, and quantum model have two pillars. One is Schrodinger wave equation and another is quantum number. Today we will explain quantum number in the details. So you can see here there is a table that I formed. This is a very brief idea which give information in very brief about these quantum numbers. The first one is principal quantum number. It identifies shells, determine the size and energy of the orbitals. As I already told you, that principal quantum number is given by Niels Bohr, And we know the application of Bohr model. That Bohr model tells us about radius of shell, energy of a shell, and everything about the shell. That means total number of electrons present in a shell. So principal quantum number explain everything about the shell. Shell is also known as orbit, and it is also known as energy level also. All three terms are used for the shell. Shell can be represented by principal quantum number n. Orbits are represented by k, l, m, n, as you already know from our lower classes like class 9. Next is azimuthal quantum number is represented by small n. It is also known as orbital angular momentum or subsidiary quantum number. It identifies subshell. We have basically four quantum subshells here. One is S, P, D, and F. And the L value of S is 0, P is 1, and D is 2, and F is 3. And it may possible that if discovery of element goes beyond 200, then we can extend this number of subshells as S, P, D, F, G. So there is a question arises in our mind that why we have only four types of subshells S, P, D, F. The very simple and logical answer is that because we already have only four blocks of elements, four varieties of elements, S, P, D, F blocks. As you know, in your periodic table contain only four types of blocks. That's why we give the name S, P, D, F. Okay. Determine. So somewhat I can correlate this quantum model with the discovery of periodic table. Why periodic table has only four blocks S, P, D, F, not other names A, B, C, D like that? Why? The reason is that because the last electron is filled inside subshell and this subshell decide the blocks of the element. So we come to the azimuthal quantum number. Determines the shape of the orbital. What about the shape? S subshell having spherical shape, P subshell have dumbbell shape, D orbit, orbits, D subshell having uh, double dumbbell shape, and F is diffuse. That means not defined. Energy of orbital in a multi-electronic atoms along with the principal quantum numbers. So this is all are about the azimuthal quantum number. Come to the next, magnetic orbital quantum number or magnetic quantum number, that is represented by ml and small m. It will give the information about spatial orientation, that means three-dimensional orientation of orbitals. That means it tells us about the different trajectory in a three-dimension format, how the orbitals or electron is circulate around the nucleus and follow the path and form orbitals. We already have a shape of orbitals. These shapes are given by can be identified with the help of M. So you can see here, this is all about the magnetic orbital quantum number. Next is spin quantum number, that is small s. Spin quantum number always have only two kinds of value. One is plus half and minus half. The electron is moving in a clockwise direction, then it becomes plus half. If it revolves in an anti-clockwise manner, then spin is considered to be minus half. Okay, so this is all about the spin of the electron. So I can again repeat this. Principal quantum number gives the information about the shell. Azimuthal quantum number gives the information about the subshell, while magnetic quantum number will give the information about the orbitals, and electron spin quantum number that is will give the information about the spins. Okay. Now there is a lot of confusion in between different terms like orbit, orbital, subshells. So I tell you that shell is a larger one, and afterward the smaller thing is subshell, and subshell contain number of orbitals. That means shell contain number of subshells, and subshells contain number of orbitals. So orbital is the smallest unit. Okay, come to the next. These are the shapes of the different kind of orbitals. You may see here the shape of p orbital is here. This is double shape. Okay, this is px, this is py, this is pz. Why we named as px, py, and pz? That represent the orientation of this orbital on axis. If they have orientation in x-axis, then it is called px. If they show orientation along y-axis, then it's pronounced as a py. As similar, you can see the orbital shape of the d orbitals. This is your dxy. That means it is a double shape and having lying on a plane, that is xy plane. That's why it's called xy. Yz, that means yz plane. This is your last is dz square. Come to the next. Apply this table to understand in a brief. So we have a brief idea about the. So we can go for the brief conclusion of all four quantum numbers. Okay. Suppose there is an atom having K, L, M, N type of shells. Okay. So shell is there K, L, M, N, and they are principal quantum numbers having value 1. Okay, as we know the relation between L and N, that means azimuthal quantum number and principal quantum number. What how we find it? We have to subtract principal quantum number by -1. Then we got by 1. Then we got azimuthal quantum number. That is very simple. So suppose we have to find the various all four values for the quantum numbers for K shell. Then N is 1. L, that means L values become 0. Possible L values, that is 0. Possible M value, that is again 0. And we already talked it about that what is the value of L for the subshells. So 0 is the value for S subshell. That's why I write S here. And this first is comes from the value of N. You can see here there is a 2 which comes from that value. Then I draw a orbital here S having only single box having two electrons. One is a clockwise direction and another in an anti-clockwise direction. So S value for the first electron is plus half while the second electron is minus half. Okay, other information which we can gather about, which we can obtain through this table, the total number of orbitals. So how we find total number of orbitals? You can count the box here. You have only single box, that means you have only one orbital here. Or you can also obtain this value with the help of this formula 2l plus 1. If you put the value of L, that is 0, so 0 multiplied with the 2, that becomes 0, plus 1, that is 1. Number of electron, you can also find it. You must know about, if a single orbital is there, it must contain two electrons, one with the clockwise spin and another is anti-clockwise spin. So their total number of electrons are 2. As similar for the shell L, n value is 2, L value is 2 minus 1, that is 1. Possible value of the L, if we have to find the possible value, then always start from the 0 and go for the digit as having value L. Suppose we have a value 1, then we have to start from 0 to 1, that is 0 and 1. So what kind of subshells are present in L shell, that is S and P. If you go further detail, then M possible values. So the possible value of M are denoted as extreme negative to extreme positive. 0 have extreme negative and extreme 0 do not have extreme positive and extreme negative, but 1 has. So extreme negative 1 is minus 1, 0 and plus 1. These are not only the digits, they represent the different orbitals, that is 2px, 2py, 2pz. And you must notice in I want to bring this in your notice that the middle, that means 0, is always a z here. So you have to always choose this z and you have to put this z at the middle one. It's not a rule here, but it is a way to define these orbitals. You can see here these three values represent the orbitals 1, 2, 3. As we know that p subshell having 3 orbitals having 6 electrons. You can count the electrons 1, 2, 3, 4, 5 and 6. So what we got? We got 3 orbitals here. If we put L is equal to 0 because we have a L value is 2. L value is L value is 1. Suppose we have to put a 1 here. So 2 multiply with the 1 plus 1 that is 3. So we got 3 here. Okay. So total number of orbitals are 3. As similar for the 0 we got 1. So total how many electrons can be filled inside the L shell? 6 plus 2 that is 8. How many electrons that can be filled in a K shell? That is 2. How many electrons that can be maximum filled in M shell? That is 10, 6 and 2 that is 18 and that is 32. The sum of all these electrons are 32. So 2, 8, 18 and 32 is the sum that we already learned in our lower classes. Okay, you can see here I want to bring your attention toward these D and F shell. So D shell have a 5 orbitals and having 10 electrons that filled inside them, while F subshell having 7 orbitals including 14 electrons. So these all are about the this is a brief idea about the different kind of quantum numbers. Okay, one more important thing is that key there is a two columns in a S block in our periodic table. Why is only two? Because of these two electrons. If we see that P block contain group number 13 to 18, there is a six column, there is a six group that is 13, 14, 15 and 16 in a P block. So why it is 6 only, not 7 or 8? Because 6 electron can fill maximum in a P subshell. As similar, each series of D block elements, that means 3D, 4D and 5D series, having how many electrons, how many elements? These are 10 in each series. As similar in F block, if you see the F block, each series of the F block, that means lanthanide or actinide series, must contain how many electron elements? These are 14. That means cerium to lutetium there are 14 elements. So this is a give the idea about the periodic table also, because the development of periodic table is based on these quantum numbers. So it relate periodic table with the quantum mechanics. Come to the next, some important point for conclusion that we obtain from by observing briefly these quantum number. The first one is value of n never be exceed over L. N is never be greater than the value of n never be exceed over just reverse. Want to be I found a correction here. I have to write L here and n here. So value of L is never be exceed over the n. That is the correct form. So you can see here L values SPDF is 0, 1, 2 and 3. Total number of electron in the shell that we already learned in class 10, that is 2n square. N is your principal quantum number having value 1, 2, 3, maybe, and so on. So total number of electron that in a subshell is 2 small bracket 12 plus 1. So these formulas may help to find the number of orbitals and number of electrons. So this is your worksheet. You have to give the each and every answer of these questions. If you got some difficulty, I will also provide the solution of these questions. You have to learn You have a lot of things to learn from this class. If you have some, if you interact with some uh, doubts, you can ask in our comment section. Okay, this is all are about our today lecture. You must note in your notebook along with the date. Okay.